In example 3.4.4, we're asked to look at the question, can dogs smell cancer? So they had looked at breath and stool samples from patients with cancer. A trained dog was given the samples and recorded how many times cancer was detected. Out of 36 breath tests, there was 33 detections, and then 37 out of 38 for the stool tests. And we're interested in finding out if there's a difference in cancer detection. We're looking at categorical data here. Just yes, no, was cancer detected? So when we're looking at categorical data, we deal with proportions. And so since we're trying to compare proportions for two groups, we're interested in the parameter, we'll just call it P1 minus P2, where one group is the breath samples and the other one is the stool samples. Our point estimate is our sample value. And so we would look at the difference in the two sample proportions. And so we could take our sample value of 33 out of 36 and subtract our sample value that's 37 out of 38. Those are our two sample proportions. And what we end up with then is a difference of negative 0.057. We want to use then StatKey to get 95% confidence intervals both under the standard error method and under the percentile method. So in StatKey, what we need to look at is going to the bootstrap confidence intervals in the middle and doing a difference in proportions. And then here we're able to enter our data. So if you click edit data, what you need to put in is the count of how many and then the sample size. So we had 33 out of 36 for the first group and 37 out of 38 for the second group. Click OK. In the upper corner, we have our original sample information, and you can see that difference there of negative 0.057 that we calculated. Then we'll click Generate 1000 samples, and here are our bootstrap samples. From that, we can get the standard error of the 0.053. And so what we end up with for our interval using the standard error method is negative 0.057 plus or minus 2 times 0.053. And then we can calculate from that what exactly we're going to have for our interval. So if you take negative 0.057 and subtract 2 times 0.053, we get negative 0.163 for our lower bound. If we go through and do the addition part, we get 0.049. Notice that this interval does contain 0, meaning that the difference in proportions could be 0, suggesting no difference in the cancer detection for the two types of samples. Then if we want to do the percentile method, what we look at in StatKey is taking the two-tail, and it'll put 95% in the middle. So we're getting an interval from negative 0.167 to 0.051 for that piece of it. And notice that is pretty close to what we got using the other method, the standard error method. And then lastly in part D, we're asked what would happen if we had twice as many samples, but the same proportion. So instead we have 66 out of 72 and 74 out of 76. We're going to redo this 95% percentile method and see what interval we get and how it would compare to what we've already obtained in part C. So if we edit our data to make everything twice as much, we'll have 66 out of 72, and then we had 74 out of 76. If we simulate again and do the two-tail, our 95% interval is now negative 0.139 to 0.012. If you compare that interval to the other one we got in part C, this interval is narrower than what we had in C. So if you keep the same amount of confidence, but you increase your sample size, that will result in a narrower interval, so better able to pinpoint where we'd expect the difference in proportions to actually be.